Hello, ladies and gentlemen. Welcome to another lesson with Professor Checo, Pre-Calculus for Business. Today's lesson is 8.1, Sample Spaces, Events, and Probability. As you can see, we're getting towards the end, so let's get to it. Let's go to Preview. And we get 26 questions, okay. Let's go straight to the textbook. Let's see what we got. Alright, so let's see. We're going to have a brief and relatively informal introduction to probability. So experiments. You have a random experiment. We simply use the word experiment to mean a random event. Sample spaces, events, so to speak, set of numbers, subset, compound event. Okay. Definition. Sample space and events. If we formulate a set S of outcomes, events, of an experiment in which such a way that each trial is experimental, you then have a sample space for the experiment. Each element is called a simple outcome or a simple event. An event E is defined by a subset of S, non-empty, moving forth. All right, I'm moving on. So here's just an example. All right, talking about that. Here's our sample spaces start. So if we were to flip a coin 3 times, or twice, right? Nickel, dime, there's your sample space, all possible outcomes. Sample space of rolling a die. So if you have 1 through 6, every single combination here is possible, and then that would be that. All right, let's keep going. Probability of a simple event is probability of that event happening over the total, and the probability of each event has to add up to 1. So here, if you have a coin, and you flip it heads tails, probability of heads is half, probability of tails, and they add up to 1. Yeah. Pretty simple. Probability of an event. We have empty set. I'm just moving on, right? That's pretty self-explanatory. You guys can read those definitions. Step to find the probability of the event. I'm just gonna get straight to the, let's see. Yes, here's the probability of an arbitrary event. Is the number of time of elements over the total number of elements. Probability of an equally likely. Moving on. These are all just like small little examples. All right, here it's approximately that. I gotcha. Oh, these are cards. Now I'm gonna be doing cards. I got that. It's cool. People, all possible outcomes. Yeah, I'm gonna go for it. All right. So without using a calculator, determine which event E or F is more likely to occur. 8 out of 9, 7 over 8. So if you were to multiply 9 times 8, you would get 72. So that would be 8 times 8 is 64, and 7 times 9 is 63. So 8 over 9 is a higher probability. E is a higher probability, therefore it's more likely to occur. So that one was 64, one of them had 63. Yeah, you just get the same denominator. I'm just going to convert. Where's Desmos? Hold on one second. If I go here, if I go edit, let me see if I'm able to add a calculator to this really quick. I cannot add a calculator. Okay. So I'm going to need Desmos. Desmos, beautiful math. Let's get this over here. Let's open my graphing calculator to my problem, which is right here. Desmos is right there. Desmos? Where'd Desmos go? There it is. Alright, so I really just only need the calculator because I need to know what 1 divided by 15 is. That's 0.066, which is bigger than 0.6, so F has a lot higher probability. And then here. So a circular spin is divided into 18 sectors of equal area. There are 6 red, 5 blue, 4 yellow, and 3 green. So the experiment of spinning is once find the probability that spinner lands on blue. So blue would be 4 out of 18. Can I write it as 4 over 18, or they want it as 2 over 9? We'll find out. And S, it's just going to be 4 over 18. How is there not 18? There are 5 blue. Where did I see 4? 4 yellow, 5 blue. There we go. Probability the spin lands on blue is 5 out of 18. Or I could divide that by, no, that's going to be it. Type an integer or simplified fraction. Yep. Alright, so now here for yellow, it's 14 sectors, 3 over 14, right? A cooler at a picnic contains 100 cans of soda covered by ice. There are 22 cans of cola, so 22, 17, 18, 43. The cans are the same size and shape. If one can is selected at random from the cooler, determine the probability the soda selected is ginger ale. So hold on, let's see. Ginger ale is 18 plus 17 and 13, so it's basically 100 minus 22, which is 78. So that's 78 over 100. 78 over 100. 78, that simplifies. So let's do 78 over 100. I got 78 divided by 100 is 39 over 50. 39 over 50. Yeah, so that's all it's really. There's no adding or subtracting. Just, there you go. Alright, an experiment consists of drawing one card from a standard 52 deck. What is the probability of drawing a jack? Well, there are 4 jacks, so it would be 4 out of 52, which is 1 out of 13, because there are 13 suits, 13 different face values, so 1 out of 13 would be that. Yep. Probability of drawing the 4 of hearts. That's 1 card out of 52. Standard jack, blah blah blah. Each suit contains blank, blank, blank. What is the probability of drawing a red 8 of clubs? 1 out of 52. The probability of choosing any card in the same deck can be determined by dividing the number of ways that the event can happen by the number. Here we are assuming a standard deck has 4 13 card suits: diamonds, hearts, clubs, spades. Yeah. The diamonds and hearts are red, the clubs and spades are black. Oh. Clubs and spades are black. What's the probability of drawing a red club? 0. That was a trick question. Sneaky, sneaky. The probability of having 1 boy and 2 girls is, in a family of 3 children, except multiple births, what is the probability of having 1 boy and 2 girls? So it would be 1/2 times 1/2 times 1/2, 2, 4, 8. So I think this is 1/8. Oh, because they repeat. 1 boy and 2 girls. Did they do a tree diagram? 2 to the 4th. It's 8. Give me an example. Hold on. What? Therefore, the number of elements. Yeah, and this one is 16. 4 choose 2. Why are you picking 2 of them? Substitute 6 into number of ways, boys. I don't get this. So is it still 3/8? I didn't like that. 5 boys and 1 girl. I'm gonna take a random shot in the dark. No. That's 6. 2 to the 6 is 64. 2? Or is it 1? No. Is it 1 over 32? 3 over 32. I think I'm onto something. Similar question. 6. 2 to the 6 is... Dang, that's a big number. What is 2 to the 6? 128? 2 to the 6 is 64. Still 64. So 3 over 32 over 64 over 32, 16. 15 over 64. Where's my combination? Combination calculator. Combination calculator. Let me just take a quick peek at this. If I were just to do, what is this? I have 4, 5, 6, 7. 7 choose 4. So what if I have 7 and I'm choosing 4 of them? What would that be? That would be 35. So here, this one should have a numerator of 35, and then that's 2 to the 7. What is 2 to the 7? What is 2 to the 7? 2 to the 7 is be 128. 128. So let's try this as 120. 28. Yeah. So alright, that makes sense. Because I have 7 children, I'm picking every combination of 4 boys and 3 girls. So I'm choosing 7 of them to be boys. The rest can be girls. Alright. Let's move on. Store carries 4 brands of DVDs, J, G, P, whatever, from past records. Find the relative frequency of choice using the given property. Blah 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 blah. Find the probability that a customer will choose a random blade J or P. J or P. So what is that? 55.55 when we add them together. Yeah. If a child in the family excluding multiple births, what is the probability of having 2 boys and 1 girl in any order? What's the probability? So that's 2 to the 3rd, which is 8. So that's divided by 8. And then I believe it's 3. If you remember, 3 choose 2. 3 choose 2 is 3. Alright, next question. Small combination lock has a suitcase has 3 wheels, each labeled with digits 10 to 10 digits. Boom. What's the probability of guessing the correct combination? So you have 10 times 10 times 10, which should be 1 over 1, 2, 3. Review the definition of probability. You multiply the 3 wheels, so it's 10 times 1 out of... You have 1 out of 10 times 1 out of 10 times 1 out of 10. Type an integer or simplified fraction. 1 out of 1,000. The answer be? Final check. 1 out of 720. Is that 3 to the 10? What is 3 to the 10? No, it's not 10 to the 3rd. How did they get 720? Similar question. Let's just view an example quickly. Let's see. No, I got that. So you have 10, choosing 2. Oh, this is 2 wheels. Oh, oh my god, I didn't even read the fact that it was repeating or non-repeating. Oh my goodness, with no repeats. Oh, this is a... Now I understand why it's permutation because, dang. Yeah, so then it's 1 out of 90 because it's what probability that you get one right. I gotcha. So here I have 4 wheels, so I have 10 choose 4. So I go back to my combination. I have 10 numbers to pick from. I'm choosing 4. Calculate. That's 210. So it should be 1 out of 210. No. It's not a combination, it's a permutation. Where is my permutation calculator? I have 10 objects. I am picking 4. Calculate. 5040. 1 out of 5040. 1 out of 5040. 5040. There we go. That's why in my earlier videos I said that like the locks that you have on like your gym locker or like your school locker, those are actually called permutation locks. Order matters. Suppose that 8 thank you notes were written and 8 envelopes are addressed. Accidentally, the notes are randomly inserted into the envelopes and mailed without checking the addresses. What is the probability that all the notes be inserted into correct envelopes? So that would be 8p8. I have 8. I'm picking 8 of them. So I think that's 8p8. 40320. 40 4830. 4320. 4320. So there's 40,000 ways you can do those 8. Yep. Oh, 6 decimal places as needed. Okay, decimals. What is 1 divided by 4320? And I want that to be a decimal rounded to 6 decimals. So 1, 2, 3, 4, 5, 6. That's going to round up. So 000025. There we go. Cool. All right, an experiment consisting of 2 fair die. Find the probability dot. The sum of the dots is 11. So here's our sample space, right? And really what I'm looking for is what adds up to 11. And I don't know if you guys know, but it's really just going to be those 2 numbers, 5, 6, and 6, 5. So that's 2 out of 36, because there are 36 total options, which if you simplify that would be 1 out of 18. So what is the probability? Type in 1 out of 18. All right. Use the sample space and find the probability that the sum of the is greater than 8. So let's find 8. 8's 4, 4. So it goes this way, and then that way. So what is it going to count? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Greater than. So that's 10 out of 36, which is 5 out of 18. I don't think I can go any higher than. That's be it. Cool. There's my fraction. Sum of the dots is 15. Not possible because the dots will only add up to 12, so 0. Probability of obtaining less than 2 tails. An experiment consists of tossing 3 fair, not weighted coins. Compute the probability. Well, less than 2 tails. What's that going to be? I think probably a combination. So here's our sample space. 4 coins. 1, 2, 3, 4, 5, 6, 7, 8. N equals 4. missed that completely. 2 parts, 1 part. Done. 3 heads is 1/2. So can I just write it? No. Obtaining less than 2 tails. I just don't want to do this. I don't want to create sample space. How can I do it without creating this? Since the heads will always occur, there are only compute the probability of obtaining at least 3 heads. At least 3 heads. There'd be 16. There are only 8 outcomes. Oh, because it's 2 to the third. It's 2 to the third. 4 regular coins occur, there would be 16 outcomes instead because 8 times 2. Okay, I understand that. So I understand why there's 8 outcomes. So here we have 4 outcomes. No, we have 2 to the second, 4 outcomes, yeah. So four hold on. So there are 8 total outcomes, less than 2 tails. 3 out of 8? I don't know. What's the answer? 3 out of 4. Similar question. 3 fair coins, except one of the 3 coins has heads on both sides, so then this is probably at least 1 tail. 3 out of 4. Yeah. A single card is drawn from a standard deck. One is interested in whether or not the drawn is a heart. So as appropriate space, it's either a heart or it's not. Would it be reasonable to make the equality likely assumption? No, they are not equally likely because that's 1/4. That's 3/4. I think it's that. Yeah. Wheel of Fortune has those colors. One is interested in the color of the point, so is appropriate sample space that. Would it be reasonable to make the equality likely assumption? So on 7 sectors, equal area colored, boom, yes, because no, it is reasonable because each sector has the same area. Assuming the wheel rotates smoothly, we can suggest that that's a thing. All right, is it possible to get 29 heads if 30 flips? Yes, it is possible because it is in the sample space. Yeah, it is possible. It's very, very, very slim. If you put 40 coins and got 38 heads, would you suspect that the coin was unfair? Yes, because it's not possible to get more than no. Yes, because it is highly improbable for a fair coin to get 38 heads and 40 flips. The number of heads and the number of tails should be approximately equal, which is absolutely correct. So regardless if you believe your coin to be fair or unfair, based on the above data, what empirical probabilities would you assume to the simple events of the sample space? This would be 0.5 and this should be 0.5. Oh, so here, what would that, what's 29 out of 30? I need a calculator. 29 divided by 30 is 0.97. 0.97 hundredth, tens, hundredth, 6, 7. So that would be What's 1 out of 30? 1 divided by 30 is 0.0333. So 0.033 tens, hundred thousandths. .95. Oh, we were on 38 out of 40. Watch that be 30 out of 40. That's BS. Oh man. 38 divided by 40 is .95. Yep. I did it on this one, not this one. Alright, you guys get that right. The probability of getting a sum of 4 has one of two opposite faces. Number on two of the opposite faces. Two fair, not weighted die, and adding a dot on the two sides. Each die has a number 1 on two opposite, 2 and 3. So really the possibilities is 1, 2, 3, 1, 2, 3. A sum of 4. So that's 1, 2, 3, 1, 2, 3. 3 times 3 is 9. So the subspace is 9. So it's over 9. No, it's over 9. And how many of them add up to 4? 2 of them. Because it needs to be 2 plus 2. Oh, 1 plus. I'm sorry. To get 4, it's 1 and 3, 2 and 2, so it's 3 out of 9, 1/3. Probably getting sum of 5 is the same thing. 5 is only going to happen with 3 and 2, so that's 2 out of 9. And then 11 popular brands of beer are used in the blind test study. Complete. If 4 distinct brands are chosen at random from 11, and if a customer is not allowed to repeat any answers, what's the probability that all 4 brands can be identified just by guessing? Um, 4 4P 11P4 7920 7920 because order matters. You're playing a guessing game. So the probability is 1 out of 7920 because you would get 4 from 11. If repeats are allowed in the 4 brand repeat answers, this would be a combination, right? Because now no, I think this is 11 to the 4th because it's 11. You have 11 beers to choose from times 11 beers to choose from times 11 beers to choose from times 11 beers to choose from. I think this is 11 to the. What is 11 to the 4th is 14641. 14641. Palindrome. No, dang it. The probability is 1 divided by 14641. Let's try that. There we go. Alright, what we got? A few questions left. A laboratory technician is to be tested on blood types from 9 standard classifications. If 4 distinct camps are choosing from 9, what is the way they could guess it? That's the same question. This literally is the same exact question. There, yeah, it's the same exact question. Moving on. Because of limited funds, 6 research centers have been chosen out of the 12 substitutes for a study of heart disease. I'm guessing it's the same exact thing. So it's just the 4 parts. So then, yeah, you would just do 4. What is that? 8 P4, and then 1 out of that. Yep, done. And the last question. Let's take a peek. A town has councils of 12 members, 5 Democrats and 7 Republicans. If the president and vice president are selected at random, what's the probability that they are both Democrats? So that would be, I think it'd be 20 over a, is this a combination or is this going to be a permutation? I think it's going to be a combination. I have 12 people, I am picking 2. Or no, I think it's a permutation because order matters. It's president, president, and vice president. So I have 12 people, I am picking 2, which makes how many options? 132. I feel, yeah. So 132. So I feel like it's 20 over 132. Does that sound right? 20 over 132. I don't feel like it's right. Let's try 20 over 132 is 0.15. So let's go here, 0.151. 2? Yeah, because you are going to be doing, you have 2 slots to pick, so it's 5 times 4. So you have 20 total options for your Democratic people. And then for your total people, it is, you have 12 people, 12 total members, and you're picking 2 of them, your president and vice president. And it is a permutation because the order matters. Who sits in the president is different than who sits in the vice president. Cool. Probably that Republicans will make up the majority is 7 times 6 is 42. So it's going to be 42 divided by that number. 42 is 318, 0.318, 0.318. The probability that Republicans make up the majority. Oh, if a 3-person committee, I didn't even read the question. Oh my God. If a 3-person committee is selected at random, what is the probability that the Republicans make up the majority? So what's 7 choose? 3. 7 times 6 times 5. And then 7. I think this is a combination. And it's going to be, I have 7 people, I am picking 3 of them. And that gives me 35. And then if I have 12 picking 3, 220. So 35 over 220. 35 divided by 220 is 0.156. That doesn't seem right. This should be much. If a 3-person committee is selected at random, what's the probability? For a 3-person committee, let's sample space be the people of 19. Since the order does not matter, find the probability of submitting the committee. 9 combination. So for me, it would have been 12, 12, 3, right? 12, 3, which is 220. I had that correct. Okay. So then 3-person committee with 2 and 3 Republicans. To find the number of elements, 10 choose 2 and 10 choose 1. The number of elements in 1. Oh, I get it. We have to do 10. So what's the probability of getting? So if a 3 committee is selected, what's the probability that the Republicans make up the majority? So we have to find the probability that it's 2 Republicans and 1 Democrat. And then we got to be a different. Yeah. So you just multiply that. You get that committee, the second committee, the third committee. Boom, add it, done. Uh, cool. Awesome. So that is this 8.1. Not too bad. Best of luck.